Shut up and sit down.
Well, hey everybody, welcome to another episode here at Master the NEC, where we talk about the National Electrical Code. And of course, today's episode, we're talking about exam preparation. If you're preparing for an electrical exam, it doesn't matter whether it's a journeyman's or a master's, or maybe you're doing an electrical inspector exam, or maybe even you're doing your engineering exam and you just want to learn the National Electrical Code a little bit better, then obviously we have programs that can help you out. Over at masterthenec.com, we have residential courses, commercial courses, Electricity 101, grounding and bonding, and obviously our Fast Trax Electrical NEC learning system, which is designed to teach you the National Electrical Code. Now, if you're trying to study for an electrical exam, I don't believe there is any program out there on the market that is more intensive, that requires you to do the work to receive the benefit, and along the way give you a lot of interactive support than our Fast Trax program. So, we're going to look at 5 questions out of the Fast Trax program. And if you find yourself struggling with these questions, and a couple of them are basic and some of them are a little bit more complicated, if you find yourself struggling with it, then consider looking at our Fast Trax program. It is probably the most affordable exam prep. You know, there's a lot of things online which are not validated, and there's a lot of things that you can invest in, but do they really walk you through the National Electrical Code from the very beginning all the way up to calculations like what we're going to go into today, some examples. So if you're looking for something, a study plan to help you be successful, give us a look, please, over here at masterthenec.com, and you'll see at the top navigation, exam preparation courses, and you can get involved in our program. All right, so we're going to look at 5 questions today. We're going to allow you to try to pause the video, work these questions out, because these are common questions that you might see on an electrical exam, and they come straight out of our program. And in our program, we teach you how to solve these questions, but we also teach you how to interact with the program and the National Electrical Code. Okay, so without further ado, let's go on and jump into the program so we can look at the questions. So welcome to Electrical Code 101, and we're going to jump into these questions, and hopefully we're going to help you answer these questions and possibly help clear up any confusion you might have with them. All right, so next one, let's go here, and here we go. First question that we're going to deal with. Also, at any time, check the website out below if you want to go look at what we have to offer. There's even a video on our Fast Trax program to kind of give you a detailed understanding of everything that's covered in the video. All right, so question number 1. What is the demand load contribution for a commercial laundry with 10 5 kVA clothes dryers and 10 1.5 kVA washing machines? Okay, so think about this question for a minute, and you're thinking about contributions. What is the contribution? And the contribution is going to be, look, is there some type of derating that can be applied to these clothes dryers or washing machines? Well, in your mind, the first answer might be, well, sure, there's a table at 220.54. However, that only applies to dwelling units. It doesn't apply to commercial applications like a laundry. So before you were to go down that rabbit hole, it's important to understand that if you look at 220.54, it clearly states that that is only for dwelling units. And we're going to do that so that you can fully understand it, as you see right here. And it's right there. It says electric clothes dryers for dwelling units. So if you're on an exam, you can probably bet that they will give you an answer for at least the dryer portion based on this table. But since it's not a dwelling unit, that's a rabbit hole you don't want to go down. It doesn't apply, right? So pretty simple here. We're going to go back to the presentation. So what are you doing? Well, you're going to have to take the total kVA of both the dryers and the washers when you apply it to your service calculation. Okay. Now, if you wanted to add each one of them independently to find out what their actual amp draw is individually, that's pretty easy to do. You simply take the total kVA and you divide it by either 240 for the dryers or 120 for the washing machines. But what we're looking for is a demand load contribution for the laundry. So we're going to work this out, and it's going to be a total value that we're going to put towards our load calculation if we were doing a load calculation for a laundromat, for example. So let's kind of look and see what's going on here. So the answer is 65 kVA. Now, I should have told you, you can pause at any time, work this out, and then you can play it and look at the answer just to kind of gauge yourself, see how you're doing, see if you're coming up with the right answers, and kind of see what your level of understanding is on the actual question. So in this case, how do we come up with that 65 kVA? Now, remember, we can't use any derating factors that are in 220.54. Can't do that. So in this case, we're specifically given values. We have 10 5 kVA clothes dryers, and we have 10 1.5 kVA washing machines. And we're trying to find out what the total demand load contribution is. Okay, so in this case, it's simply 10 times 5 kVA, or if easier for you, go 10 times 5,000 VA. We like to work everything into VA and work it that way. So in our case, 10 times 5 is 50. So that would be 50 kVA. And then, of course, the washing machines would simply be 10 times 1.5 kVA. And that would be 15 kVA overall. Now, I always like to work it in VA because that's ultimately what we're going to work our question out of. So in most cases here, I would simply take the 10 times the 5,000, and that gives me 50,000 VA. And then I would take the 10 times 1.5, and that would be 15. And then I would further break that and say that's 15,000 VA. And then I add the two together, and that would give me 65,000 VA. Okay. But 65,000 VA is equivalent to 65 K, K representing kilo, which is 1,000. So 65,000 VA. So that's how you kind of read that out. So again, that would be your contribution. Now, the reference is 220.14a, and you're thinking, why? Well, because I could not use any derating factors in 220.54, I need some direction that tells me that I have to take the value of the load. Okay, and the load value in this case for these appliances is 5,000 each for the dryers and 1.5 or 1,500 VA for the washing machines. So let's kind of go to the code so we can kind of always tie back our loop now and see what gives us the requirement here. Because if you see, we're not going to be in 220.54. These aren't dwelling units that we're dealing with. So what are we dealing with here? Oops, the wrong button for you there. So what we're going to do is we're going to go back and see what we've got here. So we are going back to all the way back here, and you see that it talks about, there we go, 220.14a, and that's where it says specific appliances. Well, that's what we've got here. We've got dryers, and we've got washing machines. It says an outlet for specific appliances or other loads not covered in 220.14b through M shall be calculated based on the ampere rating of the appliance or load served. Well, there's our load served. And of course, this one, B, starts getting into dwelling applications. It doesn't work for us. So we've got to come up with the values. We need to know what we're working with. So that's where 220.14a gives us that direction. Of course, we're going to use this value in our overall load calculation, whether we're using part 3 for the standard method or part 4 for the optional method. We have to know where to get our values, whether it's a nameplate in the optional or we're working off the minimums that are going to be under 220.54, which does tell us that for 220.54, it does say, and I'll look at it, it does say 5,000 watts, but remember, well, that's only for dwelling units. So we're going to have to use the value that's given, and that's why we use 220.14a to be able to use that 5,000 and that 1,500 directly. Okay, makes sense? All right. So in that case, we know where we're going to be, so we need to come back to the presentation. And so we did 10 times 5 is 50, 10 times 1.5 is 15. You add the two together. We use the values that afforded us in 220.14a because we couldn't use anything in 220.54. It's not a dwelling. Those are appliances, and they are specific appliances, so we're able to take the values, and we did. We took the face value of what they are, and that's where we had 65 kVA. So hopefully you've worked that out and understood where all we went for it and how we got there. Again, we're not going to use 220.54, even for the 5,000 watt, which is synonymous with VA minimums, because it's not a dwelling unit. We have to take the values from the units, okay? All right, next question. What is the minimum general lighting load for a 11,750 square foot nightclub with an actual connected lighting load of 14,060 volt amperes? Now, the tendency for people is to say, well, I'll just take the 14,060 because that is the connected lighting. However, you have to look at 220.12 in order to determine how I'm going to deal with this nightclub. Okay, so before I give you the answer, pause the video, see if you can't work it out and find out, do I use the 1460 connected load, or do I use some other value that I have to calculate out? Okay, do you figure it out? All right, so basically you're going to go to table 220.12 and you're going to look at the VA per square foot for a nightclub. Now you're going to notice something, and we'll do that. Let's go to the code, and we'll go to that area of the code. And let's see here. We're going to get off the dryers here. We're going to go back up to 220.12. We just did 14. That was for the other loads. There we go. 220.12. All right, so lighting loads for non-dwelling unit occupancies, obviously, is what we're dealing with here. Now, let's see, the lighting load, a unit load of not less than specified in 220.12 for non-dwelling occupancies and the floor area determined in 220.11 shall be used to calculate the minimum lighting load. Okay, that's the part we want to stop at, okay? Now, so I should mention, motors rated less than 1/8 horsepower and connected to the lighting circuit shall be considered general lighting loads. So that just kind of means that, in case you wondered, that just means those loads like ceiling fans that are less than 1/8 horsepower, they're already considered in the general lighting. You don't have to add anything additional to it. That kind of gets rid of that little question people had about ceiling fans and things like that. Now, if you have a commercial building that's got a huge Hawkins ceiling fan with a motor that's greater than 1/8 horsepower, okay, chances are that's not on the lighting. The chances are it's probably on its own circuit, but just kind of keeping it all real here, all right? Okay, now, let's see here. Let's look at what we're looking at here. So we have a nightclub, and I don't see nightclub in here, but I do notice the restaurant, and it has a little note beside it, a little F. And F down here says clubs are considered restaurant occupancies. Okay, so we have a nightclub, so it's considered a restaurant when it comes to using this table. So here's the restaurant, and it says 1.5 VA per square foot. So that's what we're going to use in our question. So we're going to use 1.5. Okay. All right. So let's go back to our question real quick. And let's see here. So I'm going to take the 1.5 VA and I'm going to multiply it by the square footage, which is 11,750, and equals 17,625 VA, which is greater than the 14,060 VA connected lighting load. Okay. And it says it couldn't be less. 220.12 said it can't be less than the value that's calculated utilizing the values of table 220.12. So in our case, for our question, the answer is 17,625 VA. That's going to be it. Now, in this question, they were trying to drive you towards the connected load or the connected lighting load. And in this case, the actual 220.12 calculation bore out to be a higher value. Okay, good question. Might come on an exam. The one thing I'll remind you is don't overthink this question. Okay, don't start thinking about, well, what about B option for energy savings? And no, just answer the question. Don't let the mind wander. You can do all that wandering once you get the license or you're out in the field and your engineer states otherwise, then you can have that conversation. But don't make it more complicated than it needs to be. Okay, the next question that we run into is a manufacturing plant. So it's not an office building. I'm going to say that up front for a reason. A manufacturing plant has 320 feet of multi-outlet assembly, okay, of which 60 feet will contain equipment subject to simultaneous use. What is the VA, or the volt-ampere calculated load contribution for these multi-outlet assemblies? So when I see something that says calculated load, I know that I got to do something. Okay, so I'm going to have to do a calculation. And in this case, a couple calculations. In fact, since we're talking about multi-outlet assemblies, which also are going to probably have, well, not probably are, going to have receptacles installed in these receptacle outlets within the multi-outlet assembly, I know that there's also a little table that's going to give us a little better value that we can work out, another demand value. But first things first, we have to come up with an overall value. So let's work it. Now, one thing that this question, of course, you can pause this video at any time and try to work this out yourself, and we'll give you the answer. But the first thing that my mind starts telling me is I've got 320 feet overall. Only 60 feet is for simultaneous use. So the first thing I got to do is determine the difference. So I've got 60 feet of simultaneous use that I got to deal with, and I got the remainder that is non-simultaneous use that I got to work out. Make sense? So that's the first thing that comes to mind. Secondly, I then start to think about, what does the NEC say? Because the question is being very specific about 60 feet being potential simultaneous use. But the remainder, which is 260 remainder, does not have simultaneous use. All those things start running through my mind as I'm preparing for this question on an exam. And this could be one of your calculation questions, but it also could be somebody's need in a real world. So let's work it, okay? So you paused it, you tried to answer the question, and now let's go to the answers. Okay, so overall, the answer is going to be 15,080 VA. How do we come up with that? Well, remember what I said, one of the first things that I have to think about is, okay, what portion of this is simultaneous use and what portion is non-simultaneous use? Because that's obviously going to play a role in our question. So I took that 320, I'm going to take the 60 away from that. That gives me the 260. So I have 320 minus 60, that's 260. So I've got 60 feet of simultaneous, as the question told me, and I got the remainder, which is 260, that is considered non-simultaneous use, okay? So that's the first part of our question. Now, before we get into what's on the screen, we got to go look at the code. And what we're going to do at this point is we're going to be looking at multi-outlet assemblies under 220.14H, because that's going to give us the direction first. So we're going to go to the code. And when we're at the code, we're going to be looking at 220.14, and we're going to be looking at H. 220.14H is fixed multi-outlet assemblies. So that we know that's where we need to be. Now, it says right on the screen, I'm going to read it. It says fixed multi-outlet assemblies used in other than dwelling units or guest rooms or guest suites of hotels and motels, okay, which we're not dealing with. We're not dealing with dwellings. We're in a manufactured building. We're not in an office building. We're in a manufacturing building, okay? We're not in a hotel or motel, okay? Very clear in the question. It says it shall be calculated in accordance with H1 or H2, okay? And it says for the purpose of this section, the calculation shall be permitted to be based on the portion that contains receptacle outlets. So we're talking about the multi-outlet assemblies that actually have the receptacle outlets in them. Okay, I'm sure you've seen them, like a plug mold with receptacles, devices that are in there that are actually in it. Okay, and they have multiples. Okay, so that's kind of the basis of what we're working with. Now, before we even get started in this, I like to really say, okay, well, we know what's going in it. There's going to be receptacle outlets in there, okay, to which we're going to have devices in, okay? But they're usually in these multi-outlet assemblies. Now, real quickly, we have to look at 220.14I. Now, 220.14I is what's going to give us the value for these receptacles that are in these receptacle outlets. So here's what it says. It says, we got to read it. We got to understand it. It says, except as covered in 220.14J, which is for dwelling units, and K, which is for office buildings, okay, which we're not talking about. It says receptacle outlets shall be calculated at not less than 180 VA or volt amperes for each single or each multiple receptacles on one yoke. Okay, so if I have a single receptacle, we refer to as a simplex. If it's one strap or yoke, then it's 180 VA. If I have a duplex receptacle, which is 2 receptacles on one strap or one yoke, then that is still 180 VA. If I had 3 receptacle devices mounted on one yoke, then it would still be 180 VA. Okay, remember that. So now that that's all clear, we're like, okay, I understand, Paul, 180 VA per yoke. Okay, now let's go back to H. I just wanted to set the tone there for you. And also to remind you that 180 VA is only in a commercial application. You do not use the 180 VA per receptacle strap or yoke in dwelling applications. Follow the rules in 220.14J for that. And the general use receptacles are all covered in that 3 VA per square foot. Not what we're talking about here. This is non-dwelling application. Okay, that's why we're dealing with H, and that's why we're not going to be we're not doing anything to do with dwellings. We're not dealing with office building. It's a manufactured building. Okay, in this question. All right, so let's see what we've got to do here. Number 1, it says where appliances are unlikely to be used simultaneous. Okay, and remember was our 260 feet was not simultaneous use. I think the 60 feet was simultaneous use. Okay, so we're dealing with that 260 feet. It says, where appliances are unlikely to be used simultaneous, each 5 foot or fraction thereof, and when I say fraction thereof, if my equation came out to a certain value, like a 3 feet, then that's a fraction of 5 feet. So, okay, that's what a fraction thereof. So any fraction, whether it's 1 foot, 2 foot, 3 foot, 4 foot, that is a fraction thereof. So you're going to take a 3 foot piece. If you had 5 foot, 5 foot, 5 foot, and then lastly you have 3 foot piece, that is a fraction thereof. So it's going to count as 1, okay? 1 piece, okay? And basically that 3 foot's going to be acting like it's a 5 foot piece. You get it? That's a fraction thereof, okay? So, or think of it this way, it's rounding, okay? If I have a 3 foot section, and it is unlikely to be used simultaneous, then that 3 foot section is a fraction of 5 feet. So it counts as a 5 feet. So it's kind of like rounding it to a 5 foot section. You get me? Okay. It says, of each separate or continuous length shall be considered as 1 outlet and not less than 180 VA. Okay, so there's again also where we're getting our 180 VA reference. Okay, so I kind of took you to I to give you a general understanding of 180 VA so I could talk about the devices on a yoke. But ultimately, you're still given this information in H as well. Okay, so I'm kind of giving you a twofer there. I kind of explained I, but it's in there when it comes to H as well. Good thing, right? So in this case, it is considered 180 VA for every 5 foot section or fraction thereof. Okay, so if I have 5 foot, a 5 foot, a 5 foot, and a 3 foot section, it is still 180 VA for that 3 foot sections. Okay, you with me? All right, so that's where we're going to get that. And then, of course, the next one says where appliances are likely to be used simultaneous, and that's what was stated in our question for the 60 feet. It says, each foot or fraction thereof shall be considered as an outlet of not less than 180 VA. Okay, so each foot. So of that 60 feet, each foot is going to be 180 VA. Okay, and when it comes to the non-simultaneous or the unlikely to be used simultaneously, every 5 feet is 180 VA. Okay, so with that said, let's kind of go back to our question and see how we work that out. So here's what we've got. We've got 320 minus 60, that's the 260. That is the non-simultaneous use or unlikely to be used simultaneously. And remember, it's every 5 foot section. So to find out how many 5 foot sections we have, we'll take that 260 divided by 5. We had 52 of them. Now remember it said 180 VA per 5 foot or fraction thereof. So we just take that 52 times 180, and that is 9,360 VA for that non-simultaneous use portion of a multi-outlet assembly. Now, what about that 60-foot piece? Well, remember what it says? It said 180 VA per foot or fraction thereof. So 60 times 180 is 10,800. Okay? volt-amperes for simultaneous use. So you simply take the non-simultaneous use and the simultaneous use, you add them together, and that would be 20,160 VA. And now remember something. That is before you've even applied any demand factors yet. Oh yeah, there's more to do here. Because these are receptacles, it doesn't matter that they're multi-outlet assemblies, they are receptacles. And so we're allowed to apply 220.44, a demand factor, to those receptacles. It's a beautiful thing. Let's go look at the code and we'll talk about it. So we're going to go look at 220.44. All right, so 220.44, now that we have what we got to work with, 220.44 says, check this out. It says receptacle loads calculated in accordance with 220.14H, which is what we just did, and I, so I can be applied. So this 220.44 can be applied to I as well. If you remember I, we're not utilizing I, but it could be applied, shall be permitted to be made subject to the demand factors given in table 220.42 or 220.44. Okay, so again, in our case here, we're going to be applying 220.44 because 220.42, just so you can show you here, is not one that covers what we're working with our manufacturer's building. Okay, so we're not going to use 220.42, but we are going to use 220.44. And so in this case, we take the value that we had and that first 10,000 of that value that we just worked up is taken at 100%. And then whatever the remainder is over that 10,000, it's at 50%. That's huge. And this is something that you find on exams. You have that first step that we did to totally get our connected loads, but then you have demand factors that are permitted to be applied. Okay. Now, if you in the real world don't want to apply these demand factors and you want to take that full VA value and use it in your load calc, go for it. But you get this permitted use. And we're all trying to reduce the size of our services because that reduces the cost, the size of wire, and all this type of stuff. So let's go back to the presentation and see how this works out. All right. So what we're doing here is applying it is the first 10,000 at 100%. So we're going to take that 20,160. We're going to subtract from it the 10,000. So we have something to work with the 50%. And we'll add that 10,000 at the end. So we did 20,160. Take that 10 away from it and set it aside. We'll work with that later. The remainder was 10,160. And we do that at 50%. So 50% of that is 5,080. Now you just add that original 100% that we had to take at 10,000 at 100%, add that back to it. And that's how we got the 15,080 VA. And that ultimately ends up being your contribution to your service calculation. Okay, pretty neat how that works out, right? So 220.14H and 220.44 is where you're going to go to solve this question. Again, in our Fast Trax program, we get really deep and detailed into how this works. If this is confusing to you, really consider going to this website and learning more about our Fast Trax program. It is intensive with a lot of graphics and illustrations that really hammers this stuff home. Okay, go to the next question. You're doing good. The next one, okay, is a motel has 50 guest rooms. Each room is measured 18 feet by 30 feet. It's a pretty decent sized guest room. Each room contains 8 duplex receptacles, of which one is GFCI protected. Okay. What is the general lighting and receptacle load? Now, that's a lot of information it gave you, ultimately asking you what? What is the general lighting and receptacle load after demand factors for the guest rooms in this motel? Okay. So that's a lot of questions. So feel free to pause the video, think about it, work it out, see if you come up with the same answer that we do. And we'll go look at it right now and see if we can't find the answer to this question. All right, this looks like a lot, so don't let it intimidate you. The total answer is 24,950 VA. How did we work this out? Well, first things first, each room was 18 by 30. And if you do that, that comes up to 540 square feet. Now, how many rooms are we dealing with? It's 50. Okay, and all we're trying to do is get the general lighting for the guest rooms. The question didn't ask us about a lobby. It didn't ask us about corridors. It didn't ask us about any of that. It wanted to know what is the general lighting and receptacle load after demand factors for the guest rooms in this hotel. Focus on the question, okay? In the real world, you've got other things you've got to worry about. You've got other applications you have to consider, not for the question. Always answer the question, okay? And that's something important that I go over with students all the time is, look, when you're taking an exam, put the blinders on, focus on the question, read it again, because a lot of times there's fluff that's added that's going to bring nothing to the question, but it's in there to distract you. And I don't want to distract you. I want you to focus on the question. What is it asking you? In this case, it just wants to know what the general lighting and receptacle loads are after the demand load factors are applied, which should tell you that you've got to do something. So that should be a trigger that you got to do something. And we're talking about for these guest rooms. So you have 50 of them, 540 square foot, which is the 18 by 30. So 50 times 540 is 27,000 square feet. Okay, now the guest room load computed by table 220.12 is 45,900 VA. We're going to go look at the code so you can see what we're talking about. Okay, so again, we're doing general lighting and receptacle loads. So let's kind of go back and look here. Let's go to the NEC and we're going to work this. So here we are. And we're going to go back and here's where we're going to look at, let's see here. I've got to go to 220.12. Make sure I get my bearings right here. Okay. So in your code book, you're going to go back to 220.12. Okay. So we're talking about the general lighting loads and we're going to follow up a little bit here and say, okay, we already read this before in the other questions. So we're just going to go right to the table. We're going to work on our general lighting first here. And as we go down here, we're going to see what we got to focus on in this list here. Which one do we got to use? Here we go. So we got hotels and motels. Okay. So here we see hotel and motel. Ours was a motel, I believe. And it says 1.7 VA. Okay. 1.7 VA is the value that we're going to use for our equation. Okay. So that's what we're going to use. And also, while I'm here, I might as well touch on this since, again, you'll get those questions. They'll say, okay, but what about the receptacles, the general use? Well, if you go down here and you'll notice that there is a 220.14M, and you'll notice that it says, in guest rooms and guest suites of hotels and motels, the lighting and receptacle outlets specified in 220.14 M1, M2, and M3 are included in the minimum unit loads in table 220.12. So that 1.7, that covers the general use receptacles. Okay, that covers all of those that we're considering. It covers the bathroom receptacle. Okay, it covers that GFCI I was mentioning. It covers all that already in that 1.7 VA. So relax. You didn't have to do anything really excruciating to understand that. But again, understand that that's included in it. That value is covered already in that 1.7. Simple? Okay. All right, so let's see. Let's come back to me and let's go back to the presentation and work this thing out. All right, so we took it and that's how we got that 27,000 times 1.7, and that's how we got this 45,900 VA. Okay, now, once we have this value, we read in the question that we can apply some demand factors to that, and we can. We can apply 220.42 to this because 220.42 has hotels and motels figured into the table. So let's go to the NEC and let's look at that table, 220.42. All right, so here we are. Let's go on down. Here we go. So 220.42, general lighting, it says the demand factor specified in table 220.40 shall apply to that portion of the total branch circuit load calculated for general lighting. They shall not be applied to determine the number of branch circuits. So we're not using that value. We're not using any here to calculate the number that we need. Okay. because that's something that's either, in this case, probably going to be defined by the engineer or the designer. We're just trying to calculate the demand factors at this point. We already knew in the question how many it gave us. It's irrelevant for our question. So what are we working on? We're working on right here, demand factors. And if you ever want to wonder in a calculation whether or not you can apply these demand factors, just look at the list. Because if it's not one of these here, then it would be all other. And if it's all other, then there is no demand factor. You're going to take it at its full value. Okay, so you can rule that out right away. In our case, motels are listed under here. So we're going to do the first 2,000 or less at 60%. So we're taking that first 20,000 and we're going to do it at 60%. And then from whatever you got left from 2001 to 100,000, we're going to do it 50%. And then any part of that that's over 100,000, we're going to do it 35%. Okay. It's very similar to what we do with the dwelling unit. Okay. So let's go back to the PowerPoint and work this thing out. All right. So first thing, this first one again was how we're going to work this out is, okay, break it down. So the first 20,000 is at 60%. So as you can see here, and right here, it was the first 20,000 demand. So it's 20,000 times 60%. That's where we got 12,000. So you set that aside. All right. And then the remainder of that over that was what? 12,950. Okay. So that was the remainder value that we have. Okay. So in that case, and let's work this out to make sure, because I always like to make sure that my question is right. Okay. Always want to make sure the question is right. So in this case, it was, let's go on and take that 45,900 and minus the 12,000. No, let's see here, 45,900. So we took that first 20,000 at 60%. So 20,000 times 60%, and that is 12. So what's over that? Well, the remainder over that was what? 25,900, right? Okay, so the remainder, 25,900 of that total value is going to be applied at 50%. So I'm going to multiply that by 50, and that is 12,950. So you see what we did here? So the first 2,000 at 60%, you write that down. The next value over that 20,000 up to that 45,900 was 25,900. You take that portion and do that at 50%. Okay. And that's where we got the 12,950. Okay. Now you just add the two together. And in this case, it was 12,000 plus 12,950. You add the two together, and that was 24,950. And that's where we got our VA. It's pretty simple. Again, go up to 20,000. In our case, it was 45,900. So the first 20,000, take that bulk amount and multiply it by 60% and write that value down. Now, start at that 20,001 and go up to whatever the value was, which in our case was 45,900. So what's the amount over the 20 up to the 45,900? That was 25,900. Take that value and do that at 50%. And that value came out to be 12,950. So you add the 12,000 and the 12,950, you add them together, and that is your VA. And in fact, that is your demand value after you apply the ability to utilize table 220.42. So that's how we came up with our answer, 24,950. Not overly complicated, but I think you get that it's something that if you don't really follow the pieces, that it can get confusing. And in this one, it's very important to remember that you take the first 20, work it, and then take the value over 20 and then work it at a separate percentage. Okay. That keeps people from getting totally confused on how that works. Again, if you're confused, go to our website, check out the Fast Trax program. It actually breaks it down piece by piece so that you have a better understanding and gives you visualizations and graphics and things like that. And there's even videos as well in interaction. Okay. So check that out. All right, let's go to the next one. So the last question we have is a restaurant. Now, this is very common on an exam. Okay, we see these questions on exam quite a bit, and this one's going to be asking about the feeder load, okay, of these commercial kitchen equipment. Okay, so a restaurant contains the following commercial kitchen equipment. It's got one 12 kW range. It's got one 2.8 kW mixer. It's got one 4.2 kW deep fryer. It's got two 0.8 kW soup wells and one 6 kW water heater. Now, the question simply asks you, what is the feeder demand load? So the demand says I got to do something. It tells me that I got to apply something. What is the feeder demand load in kW for this equipment? Now, important, it wants to know what it is in kW. This is an example where on an exam, they want to know the values, and they might give it to you in VA. They might give it to you in kW. You need to understand that since it asked for this in kW, I want to give the answer in kW. Okay, so take time, figure this question out. And again, we're looking for, we're making sure what the load is for this on a feeder that's going to be supplying all of these pieces of kitchen equipment. So do you know the answer? If not, well, you need to look at the Fast Trax program because we're going to explain it. So if you calculated all this out, you'll know that it's 18 kW. Of course, the first thing you're going to do, and we'll look at the code, but the first thing you want to remember is that you've got to take the values that are given you here. Okay, this is not a dwelling application. This is a commercial kitchen. Okay, so there's a code reference under 220.56 for commercial kitchen equipment. All of this falls within that kitchen. Okay, so it's a restaurant. So we've got 12 kW range. We had one 2.8 kW mixer. We had one 4.2 kW deep fryer. We had 2.8 kW soup wells. Guess they don't pull that much. And then we had one 6 kW water heater. And we're trying to find the demand load in kW now for this equipment, for this feeder. All right. So if you added them all up, 12 plus 2.8 plus 4.2 plus 0.8 plus 0.8, 0.6 plus 6, I'm tongue-tied, that's 26.6. All right. Now, demand factors. You're saying, okay, now I get to apply the demand factors. How many appliances do we have here? There is 1, 2, 3, 4, 5, 6. There's 6 of them total. Okay. All right. So let's go to the code, and we're in 220.56. And 220.56 is right here. And we're talking about kitchen equipment. Again, we're talking about other than a dwelling. So again, this one is dwellings. This is other than a dwelling. And we have 6. So we're going to be here where it says 6 and over. Now, let me read you this because this is very important to understanding the question, because on the exam, they're probably going to give you the value that you added up, thinking that you had a total of 17 or whatever value it was. I can't remember what it was. What was the value? It was 17.29 when you added. Oh, no, it was 26.6 total, right? But you know you get to apply demand factor. Okay, so that's why you came to 220.56. Now, let's be clear. If you wanted to use the total 26.6 in your load calculation, you're perfectly able to do that. You're permitted to use this demand factor or demand calculation. But if you wanted to take the full amount in the real world, if you want to and you want a bigger service, go for it. But you're allowed to apply these demands. Okay. So let's look at it again, making sure that we're totally clear. When you look right here, it says, okay, it says it shall be permissible to calculate, again, permissible statement, to calculate the load for commercial electric cooking equipment, dishwasher booster heaters, water heaters, and other kitchen equipment in accordance with table 220.56. These demand factors shall be applied to all equipment that has either thermostatic control or intermittent use as kitchen equipment. Okay. Now, it says these demand factors shall not apply to space heating, ventilating, or air conditioning equipment. So just a statement there saying that's not going to apply. This is very much for dealing with the kitchen equipment. Okay. We have other rules that deal with the heating and air conditioning. We have other rules that are going to deal with space heating, things like that, ventilation. Not what we're doing here. Okay. So in our case, One of the most important aspects that you need to remember, and I have students all the time highlight this, provided you're able to highlight in your state. You got to check your bulletin to see whether what you can do in your code book and what you can't do. Don't say Paul told you you could highlight something and then your state says you can't. That's on you. That's your responsibility to check. It says, however, in no case shall the feeder or service calculated load be less than the sum of the largest two kitchen equipment loads. Now, let me tell you what people do on an exam. So here you see that it's a 65% demand factor that we can apply. You right? You with me? We're all good? And you remember what it says. In no case can it be smaller than two largest pieces of kitchen equipment. But let me show you what they do on the exam, and I don't want you to make the same mistake. So we added these up. We did 12, 2.8, 4.2, 0.8, 0.8, and 6 was 26.6. And we applied the 65% that affords us that into 20.56. So that was 26.6 times 0.65, and that is 17.29. Now, you can bet that one of the answers on the quiz is going to be 17.29. However, that note was very important. As it says right here on the screen, the feeder demand load can never be smaller than the total kW rating of the two largest pieces of equipment. And in our case, the two largest pieces of equipment is the range and the water heater. So that 12 plus that 6, which are the two largest, together is 18. So don't get caught on an exam and it looks like the answer would be 17.29, but it's not. It can't be less than the two largest pieces of equipment. In this case, it was what? It was the range and the water heater. Those were the two largest pieces of equipment that we had to deal with. Okay? So hopefully you got something out of that. And I will remind you that you can learn all about our programs here on our website. This is examples of the Fast Trax program. You have 12 months access, 365 days, 24/7. Everything you need to know to pass your electrical exam is in our program. You also get to meet with me every week. You get to ask me questions in our Zoom training that is exclusive only to our Fast Trax students and those supporters that are at the general and VIP level of our YouTube channel support. You have unlimited flashcards internally, and I'll show you in another video how to use these flashcards. That's an amazing tool. We cover code, we cover calculations, but there's over 1,200 real exam style questions built in, like the ones that we saw today. Okay, so all of those type of things. Hopefully you got something out of this video to help you learn a little bit about the calculations. Again, if you want more information on our Fast Trax program, go to masterthenec.com, and at the top navigation, I want you to simply click Electrical Exam Preparation. Read more, watch the demo. I'm really here to help you, and I think our program is like no other. You don't just get books, you don't get DVDs, you get videos, you get electronic books, you get interaction, you get classrooms, you get flashcards, you get everything immersed in this program. So hopefully you get something out of that, folks. Until next time, stay safe, God bless, and we'll see you in class.
Shut up and sit down.